So this is the solution by me. This is the file of question bank version 4 and about the differential equation or Maclaurin series. So I'll pick some questions and make some records. So if it is, if I think it's not, it's no need to make a record for the simple questions, then I may skip them. So in that case, if you get confused still, please make a comment on this video. Then I will give you the answer. So like this number 1, this is about this Maclaurin series, and also it will be used for to solve this the limit. So here 1a, you can use the chain rule to find the derivative, so I will skip it, but I will use that fact like f prime of x is equals g of x and g prime of x equals f of x. So here first the 3 non-zero terms. So let's find from f of 0. F of 0 is 2 e to the power of 0 and e to the power of negative 0, which is 0, so which is 1. So f prime 0, f prime x is g of x. So we make it to e to the power of 0, e to the power of 0, which is 0. F double prime of 0, actually if we make f double prime here, then this becomes g prime of x. So f double prime of 0 means f prime of 0 means f prime 0. No, f of 0, which is 1. So f triple prime of 0 should be g double prime of 0 is f prime of 0 is 0. So because we need to find 3 non-zero terms, so far we have 2 non-zero terms, so we need to go further. So here this is first derivative, which is g triple prime of 0 f double prime of 0, which is 1. So here first the 3 non-zero term will be x, from constant 1 plus x squared of 2 factorial plus x to the power of 4 and 4 factorial plus further f of x. So we use this for the find the limit of the c. Limit x goes to 0, x squared 1 minus 1 plus x squared 2 factorial for 4 factorial. So this is removing the 1, so now we don't eliminate 1, so we don't have any more the constant term. So now we have this negative and blah blah blah. So I will make the factoring with x squared, then e factorial and x squared over 4 factorial x squared. So when x goes to 0, all those terms goes to 0. So the answer is 1 over 2 negative. And here, let's make the 2a here. F of x is the square of ln x, and g of x is ln f of x. So f prime of x is, this is like a chain rule. So f of x is u squared and u is ln x. So when we go through this chain rule, this is 2u, so 2 ln x times u prime x 1 over x. So this is f prime of x. This one again ln u, but let me call it v, and v is f of x. So g prime of x is 1 over v times f prime of x, because of v prime, and f prime of x will be found there. So 1 over f of x times f prime of x, 2 ln x, and 1 over x. So now we don't have this one anymore, x ln x, and numerator 2. So now show that g of x is increasing on from 1 to infinite. So from 1 to infinite, x is larger than 1 anyway. So ln x is larger than 0 because ln x seems like this and this is 1. So this part ln x is larger than 0 for x includes 1 to infinite. Just for the reference, this is like this reversed squared bracket is equal to this round bracket, which is exclusive. So this is positive, positive, positive. So this is always positive, which means g of x is increasing function in this interval. And to b. So now we have this differential equation. Let's find it for the the linear integrating factor form. So we need to make this dy over dx with coefficient of 1. So ln x should not be here. So let's divide by ln x, then dy over dx plus 2x ln x times y equals 2x minus 1 ln x squared. So px is 2 over x ln x. So integrating factor e 2x ln x dx. So now in terms of this integration, we can figure it out. We need to do this substitution, integration by substitution. So ln x should be u, then 1 over x should be du over dx. So dx is x du. So e integral x, we don't know, u dx is x du. So e to the power of 2 ln u, which is u squared. So this is a u squared, but u is ln x. So ln x squared is the integrating factor. So let's multiply everything, every term with by ln x squared. So ln x squared dy over dx plus 2x ln x times y equals 2x minus 1. So on the left side is ln x squared times y d over dx. So 2x minus 1 becomes dx, integral. So here ln x squared times y equals x squared minus x plus c. So y becomes x squared minus x plus c over ln x squared. But this is general solution. The general solution has the constant c as it is unknown. But I gives us the condition this passes the e comma e squares. So now e squares goes to ln e squares minus e plus c. So this is 1 anyway, so c should be e. That's why the result comes like this. So sketch the graph. Yeah, you can go through the calculator, GDC. So actually we don't have a power series in our curriculum. So if you see any of these power series questions, you can skip it. And this one, A and B continuous and differentiable. So it is continuous when this like broken interval, the x value is 1, because on the left side of x has a different function and right side also has different function. So on both sides it defines with different functions. So we need to make them meet when x equals 1. So when x equals 1, actually this is from left side. So let's say from left side and from right side. So from left side, this graph goes to e negative 1 to 1, which is 2e. Oh, sorry. So 2 over e. And when x comes from the right side, so this comes a plus b. So this and this should be together. So 2 over e need to be a plus b. So this is, we just checked whether it is continuous or not. Continuous is whatever the graph is. This is not continuous, but if I make it like this is continuous. So this is from left side and this comes from right side. So just now we found the value which is approaching from their side for both. So we need to add, so they should be together, equal. So now differentiable is again same, but this need to be, so f of x should be meet there. This one should be f prime of x should meet at x equals 1. So x equals 1 from left side, x equals 1 from right side. So left side, this one, so we need to find the derivative of that. So u e negative x cube, u prime could be negative 3x squared, and e negative x cube, and v negative x cube 2x squared plus x, v prime negative 3x squared plus 4x plus 1. So on the left side, it should be follow this, but let me put 1 as I just write it down. So e negative 1, negative 3, 4, 1 plus negative 3 e negative 1 times negative 1 to 1. So this is the derivative from left side. So derivative graph will be follow this, like this, the result of this, the product rule. It will follow that function, that graph, and it goes to 1. And from the right side, this follows from here, and they should meet together. So a equals, this is 2, and this is 2. So 2 over e minus 6 over e, so negative 4 over e. So in that case, b should be 6 over e. So we found a and b. And the differential equation of this one, you know, this is the substitution case, like a homogeneous case, because this is y, x, xy, like two variables in square root, in the square root, which means it comes like degree 1. But if it is a little bit confusing, we will make it like this. Let's divide by x on both sides. So dy over dx. Sorry, I will skip Euler method. Dy over dx, and we can divide by x. X, when it comes in the square root, it becomes x squared. So now it's like xy over x squared, so it's over y over x. When we express it as f of y over x, actually this is the homogeneous case. So now we made it like that. And when we make a substitution, y equals vx, and dy over dx becomes v plus x dv over dx. So this one, v plus x dv over dx And v is y over x, so now v 1 plus square root v. So x dv over dx becomes v 1 plus square root x minus v. Oh, square root v. Yeah. So here 1 plus square root v, v minus v minus v square root v. Okay. So now dv v square root v 1 plus square root v equals 1 over x dx integral minus. I left the negative sign on the right side. So here, this is not something difficult. When we make it like this separation, then it will go to v negative 2 over 3, 3 over 2 plus 1 over v dv becomes negative ln x plus c. So negative 3 over 2, when we make it negative 1 over 2, so negative 2 v negative 1 over 2 plus ln v becomes negative ln x plus c. Here x and y is always larger than 0, so actually we can remove the absolute value symbol easily. So now oh yeah, so b was here, sorry, now I'm solving the ci. So fx of y, because this is difficult to make it like this explicit form, which is y equals something. So here we will leave the expression of x and y on the left side everything and make on the right side 0. So here as v was y over x, so negative 2 and y over x negative 1 over 2 plus ln y over x plus ln x minus c equals 0. When they meet together like here, because this is a logarithm, we can apply the logarithm law, so this is ln y. So let's make it a little bit simpler. Negative 2 square root of, so negative 2 square root y over x, but this is a negative exponent, so I'll make it reciprocal, plus ln y minus c equals 0. But we have the initial condition, which was x when x equals 1, y equals 2. So negative 2 square root 1 over 2 plus ln 2 minus c equals 0, which is c. So when we put it here, negative 2 x over y minus 2 square root 1 over x plus ln 2y should be 0. So this may be the answer of CI, and you can find the II as you input x value in this equation. So maybe you need to use the solver in your GDC. And this one, 8a, integrating factor is x equals to ct. Integrating factor is e negative 1 over t integral t. So this is ln t. So e ln t, which means e ln 1 over t is 1 over t. So this is the integrating factor. So dx over dt times 1 over t minus 1 over t squared times x negative 2 over t squared. So on the left side, d 1 over t times x over dt becomes negative 2 over t squared. So when I move the t on the right side and make the integration, then x over t is t negative 2. So negative 1 to t plus c. So now x equals 2 plus ct. Oh, so now we found it. So we showed it. So the next one. So this is what we found. Maybe it's linked to the next question. So now this is the weight of the dog 2 weeks after being bought from a pet shop. So WT continuous. So continuous should be X when T is 5. So which value on both sides is approaching? So T 5 minus, which is from negative side, 5 plus from the right side. From negative side, we can apply that one. So 2 plus 5c. On the right side is 16 minus 7, which is 9. So this and this should be together. 2 plus 5c is 9. So c is 7 over 5. So hc. The weight of the dog when bought from the pet shop, which is when t equals 0, and upper bound. So when t goes to infinite, like a larger number, then what is the weight? So from here, when t equals 0, we follow this one. Now we know what is c. Even when we don't know the c value, we can find the initial weight, so which was 2 kilos. And when t goes to infinite here, and then this goes to 16. So this is 16 kilos. And let's go to the next one. So here, this is the Maclaurin series of the arctangent of x. But this is also like the geometry series. The sum of the series is... So anyway, at this moment for question A, it shows we need to consider this series as a geometric series, which has the first term is 1 and ratio of negative x squared. So when we see the formula for this infinite sum of geometric series here, we have u1 over 1 minus r. So this becomes 1 plus x squared. And next one, so arctan x shows the expansion of. Okay, so let me continue from here, because 1 over 1 plus x squared is 1 minus x squared, x to the power of 4, and x to the power of 6 is given. No, we already know the antiderivative of 1 over 1 plus x squared is the arctangent, like this. So this one can be arctan of x is x minus 1 over 3 x cubed, 1 over 5 x to the power of 5, 1 over 7 x to the power of 7 plus c, actually. But because now we know arctan of 0 is 0, so when we put 0 here, this becomes 0, and c plus 0, 0, 0, 0, 0, all 0. That's why c becomes 0, and we have only this one. So when we integrate the expression on one side, as we did so far, we always consider the constant integrating constant of c. And 10c is not on our, let's go further. So now we have f e to the negative x and cosine x plus x minus 1. Here actually it says by finding suitable number of derivatives of f, which means we need to find the derivatives. We don't use these special cases in our formula booklet. So let's do that. F of 0 now is e to the 0, 1, 1 minus 1 is 1. Ah, 0 minus 1, so 0. So f prime of 0, u v, e to the power of negative x cos x plus e to the negative of x. Sorry, here, negative e to the negative of x cos x, negative sine x plus 1. So this f prime of x, and when we put x 0 into x, then we find negative 1 and 1 minus 0 plus 1, again 0. Double prime of x, negative e to the power of negative x cos x minus e to the power of negative x sine x minus negative e negative x sine x plus e negative x cos x. So when we simplify them, cos x, this is cancelled. So we have 2 e negative x sine x. And x equals 0. When we put x equals 0, should be 0. Another one, e, actually this was the derivative of e to the power of negative x sine x. So let me just use that again. Plus e negative x cos x. So now when we put 0, you add 1. So this becomes 2. So first non-zero term comes from the third derivative. So f of x is 1 over 3 factorial times 2x cubed. So 6x cubed, 1 over 3x cubed. And this one, this is the solution of differential equation of this. So now dy over dx plus 1 over xy, 1 over x times f of x. So now we need to find integrating factor, e to the integrating of 1 over x, which is ln x, is x. So x dy over dx plus 1 times y equals f of x. So x times y d equals f of x dx. Integral. xy becomes integral f of x dx. That's why y is 1 over x f of x dx. So this is the solution of this kind of format. So now we have here, which our f of x is x to the power of 1 negative 1 over 2. So this is the solution. So y equals 1 over x integral x negative 1 over 2 dx. So 1 over x. So we need to understand in the integral only f of x are there. 1 over x is out of the integral, so we don't integrate it. So now 2x 1 over x 1 over 2 plus c. So square root of x, 2 over square root of x plus c. Given 2 becomes 2 over 2 plus c. Therefore, c equals 1. So the result is y equals 2 over square root of x plus 1. And let's go further. So differential equation is this one. So we use the same equation to find, three different approaches to find the solution. So first, separating the variable. So y dy dx over x. Ln y, x and y are positive, so I don't need any the modulus sign. So ln x plus c. So let c is ln a, then ln y becomes ln x plus ln a, and y equals ax. So this is the answer of the A. And number B, homogeneous y equals vx dy over dx. Vx dv over dx. So vx dv over dx becomes vx over x. Don't forget, when we make this differential equation with homogeneous, we try to rewrite without y. So now here we don't have any y, which is correct. So v plus x dv over dx equals v. So v dv over dx equals 0. Which means dv over dx equals 0. When the derivative is 0, which means it is constant, so v is c. That's why when we differentiate it, it becomes 0. So v is y over x, c. So y cx. So it is the same form. And differential equation, integrating factor, dy over dx minus y over x equals 0. So e to the power of integrating negative 1 over x dx, e negative ln x, e ln 1 over x becomes 1 over x. So 1 over x dy over dx minus 1 over x squared plus y, times y equals 0. So here, again, 1 over x times y, when we differentiate it, becomes 0, which means y over x should be constant. Therefore, y equals cx. Again, same form. And D, when x equals 2, y equals 20, c equals 10. So y equals 10x. Therefore, y is 4 when x equals 5. 50. And differential equation, all the methods. Let's go further. This is Maclaurin series. Ln 1 plus x shows. Let's do that. Here 1 plus x is there. So 1 plus x, x minus x squared of 2, x cubed of 3. So now when we expand them, the term of x is only x. Term of x squared, 1 minus 1 over 2 x squared. Term of x cubed, negative 1 over 2 plus 1 over 3 x cubed. Something like that. Maybe we can go another one more following the pattern. For the x to the power of 4, negative 1 over 4 plus 1 over 3. So in this case, when we need to express it with this the sigma notation, we'd better use the same, try to make the same pattern. So now we exclude x here. So we will make them same. So if we consider this 1/1, then 1/1 minus 1/2. So smaller, larger, only denominator. Smaller, oh, this is larger, smaller. So let me put them in the same way. And this one smaller minus larger. So let me take out the minus negative sign. 2 minus 1/3 x cubed. 1/3, 1/4, x to the power of 4. So in this case, x plus this one, we can say x to the power of n, 1/n, and minus 1, for example. But this is alternate, plus minus, plus minus. So negative 1 to the power of the squared and fourth, we need to make positive, and third, we need to make negative. So this should be n. So when we simplify that, this is like nth term. n minus 1, n, 1, x to the power of n. So sigma n starts from 2, from our side, from here, to the infinite. Negative 1 to the power of n, and minus 1, n, x to the power of n. But the problem is, this is not the same form as we need to show. Here it starts from 1, and we have n here, but it has n plus 1. So let's put n plus 1 into n. Then x plus n plus 1 equals 2, infinite, negative 1, n plus 1, n plus 1, x, n plus 1. So this becomes, this is n starts from 1 to the infinite, negative 1, n plus 1, x, n plus 1. So now we showed. Taylor series is not in our area. So integrating factor, tangent of x. Tangent of x should be like sine x over cosine x. And cos x should be u. So negative sine x du over dx. So this one, negative sine x over u. Dx is sine x du. So negative ln u, which is ln 1 over u. So we put on the e, which is 1 over u. So integrating factor is 1 over cos x, which is secant x. So when we solve it, 1 over cos x plus, let's call it secant x. Secant of x dy over dx plus secant x tangent x times y cos x. And left side is a secant of x times y derivative cos x dx, integral. So y secant of x becomes sine x plus c. So this is 1 over cos x. So when I want to cancel it out, I need to multiply cos x. So y becomes cos x sine x plus c times cos x. So when x equals 0, y is 2. 2, 0, c. Therefore, c is 2. So the answer is y is cos x sine x 2 cos x. So let's go further. Acceleration over curve. Acceleration is dv over dt. It's 1 over 40, 60 minus v. dv 60 minus v becomes 1 over 40 dt. Integral. So negative ln 60 minus v becomes t 40 plus c. So from rest, which means that when t is 0, v is 0. So we need to find, okay, when t equals 0, v is 0. Negative ln 60 is c. So now we know c is ln 60. So I move here. Then ln 60 minus ln 60 minus v, which is 60 over 60 minus v, becomes a t over 40. So 60 over 60 minus v. So I don't need to actually rearrange it in terms of v. So, I mean, make the velocity as a subject. So from here, let me input the t, 30, and find the v. Then ln 60 over 60 minus v is 3 over 4. So 60, eventually we need to do that. So 60 e to the negative 3 over 4 is 60 minus v. So v is 60 minus 60 e to the power of negative 3 over 4. And this differential equation show that this satisfies the differential equation. This actually, usually when we have the question of show that, we need to like the thing that mentions here as a result. But in this case, because this says a show that, but this is almost like a verification. So when we verify something, we can use that result. So for example, y equals cos x plus sine x, dy over dx, negative sine x plus cos x. So when we multiply them together, y times dy over dx, cos x plus sine x, cos x minus sine x, cos x squared minus sine x squared, which means cos 2x. So we should. And general solution of differential equation. Yeah, I think you can find it. So let's go further down. Oh, okay. So different solution. Yeah, we need to go further. So let's continue. Y dy is cos 2x dx. So y squared over 2 is sine 2x over 2 plus c. So y squared sine 2x plus c1. Let's call 2c as c1. So y becomes plus minus square root to sine 2x plus c1. The number in the square root should be larger than or equal to 0. So, and we know sine 2x, the minimum of sine 2x can be negative 1. So negative 1 plus c1 should be larger than or equal to 0. So c1 should be larger than or equal to 1 to guarantee the numbers, the possible numbers in the square root be valid. And 24b, so same differential equation, but we don't know, now we can define, we have the condition here. So when x equals pi over 4, y equals 2. So in this case, y is 2, so we use only plus. So sine pi over 2 plus c1. So c1 should be 3. And so y becomes sine 2x. This is not plus minus sine 2x, because if it is minus, we cannot get y equals 2 when x equals pi over 4. So in this case, we use only plus 3. So reason all is xy plane bounded by c, x in vertical line x equals 0 and pi over 2. Area of all, so 0 to pi over 4, square root of 3 plus sine 2x. Yeah, I think this is the what is that? The calculator. And volume generator, pi 0, above the line y equals x. Okay, this is a little bit, I think we need to draw the graph to see how we can compose the equation. So here, this is n square. So let's make it square root sine 2x plus 3. So this looks like this. And y equals 1. When y equals 1, this is like this. Above the line y equals 1. This is already positive. 0 to pi over 2. So anyway, this looks like this. Pi over 2 was 2. So maybe this is pi over 2. And when it is 0, square root of 3. So anyway, maybe this part. So only this one will be going around the x-axis. So we can imagine the solid will be made when we rotate around this, the farther part from the x-axis, it will make the larger volume. And when we rotate this one, it will make a smaller volume, and we make the whole. So we need to subtract it. So integral pi 0 to pi over 2. This one squared, so 3 plus sine 2x minus, this is because it should be y squared, but y is 1, so 1 dx. So you can integrate it. And the next one, we already know the sine t over t when t approaches to 0 is 1. So now we try to make this one limit x goes to 0 for x squared, sine 4x squared minus sine 9x squared. So here 4x squared, this is 4x squared, but 9x squared, because here the hint shows t and t, which is the same. So this becomes 1. But this cannot be 1. So let's take out 4. And make 9x squared. But this one is just unexpected, so I need to remove it by multiplying on the different side. So like this. So 1 minus 9 over 4. So this is a negative 5 over 4. And 25 would be sine x to show that. So this also to make the pattern from here. X minus the, so this has only the odd degree. So x cube, x5, something like this. So this one, actually, we can consider it has the denominator 1 factorial. Then 1, 3, 5, because we already studied the arithmetic sequence and also general form for this odd number. So when we start from 0, we can say 2n plus 1. So factorial. And this has the same, 2n plus 1. And here, we need to make this negative or positive. 2, 0 plus 1, 2, 1 plus 1, 2, 2 plus 1. So when this is odd number, we need to make negative. So this is n. Can be n equals 0 to infinite. So this is the series of sine x. But now we need to show sine x squared, which has x squared instead of x. So sine x squared becomes 0 to infinite 2n plus 1 factorial minus ln and x squared and 2n plus 1, which makes 4n plus 2. So let's go further. So we need to sketch the graph of f prime of x. This is f of x. So now we will try to draw the f prime of x. So this is the minimum point. It looks, this is like a symmetric. So this is minimum point. Minimum, when f of x has minimum or maximum, f prime of x most probably 0. So 0. So this is increasing and also concave up. Actually all of them are concave up. So this goes to infinite. So we cannot just do it like this because it's increasing, but it doesn't reach somewhere. So it just go to, I'm talking about the slope of the tangent. It doesn't reach anywhere. It just go to infinite. So this still has the same asymptote. So it seems something similar like this. And this can be y equals f prime of x. And p of x is the Maclaurin series of f of x, and a is larger than 0. P of 0 is something here, y-intercept, which is larger than 0 on the graph. So this is justified. B, C, D, because this is a Maclaurin expansion, so B is the f of 0, f prime of 0. C is the f double prime of 0 over 2. D, f triple prime 0 over 6. Since this is 0, this is 0. And this is concave up. This should be larger than 0. And we need to see this graph. Even function. So even function, we need to remove the factors of this odd side. So this is the coefficient of x cubed, which should be 0. So B is 0, C is larger than 0, D is 0. And this is not on our curriculum. And differential equation x and y, this is a homogeneous. Squared, 2, which is a squared. So now, but if somebody asks you to show that, we need to show dy over dx is y over x squared plus 3 y over x plus 2. So y dy over dx is expressed of the function of y over x. So this is the homogeneous equation. So v, y equals vx, dy over dx is v plus x dv over dx. So v plus x dv over dx equals v squared 3v plus 2. So x dv over dx is v squared 2x plus 2. So v squared 2x plus 2 dv 1 over x dx integral. Here, because we have nothing on numerator, so it is not the substitution form, and it is not factorized, factorable, which is not for partial fraction. So this one I can say 3 plus 1 squared plus 1 squared, which is 1, and ln x plus c. So on the left side, this is arctangent. Arctan 3 plus 1 ln x plus c. So 3 plus 1 tangent ln x plus c. When x equals 1, y equals negative 1, and v equals negative 1. So 0 is 0 plus c. No, I mean tangent 0 plus c, which means c is 0. Therefore, when v is y over x, so y equals x tangent ln x minus x. This is the last answer. So this is not on our curriculum. No, let's go further. So now 29a, this is like 0 over 0, which is, and also fractional expression. Fractional expression indeterminate form, which is 0 over 0, 0 over 0, or infinite over infinite. So we will make it, we will go through the L'Hopital. So we need to write it down here. Then we will go to the next step with L'Hopital. So limit x goes to 0, secant squared of 0, x 1 plus 2x. So this is 1, 1, and this is 1. When it determines, then that's the answer. And this one, x goes to 1. This is also 0 over 0. 0 over 0. So we will make it L'Hopital. X goes to 0, 1. And 1 is not there anymore. Negative pi over 2 cos pi x over 2. Negative 2x plus 4x ln x plus 2x squared and 1 over x, like this. So when it is 1, still 0 over 0. So let's go to another one. And pi squared over 4 sine pi x over 2. Oh, sorry, this is 1. Negative 2 plus 4 ln x plus 4 plus 2. So when I input 1 into x, this goes to pi squared over 4 and 4. So eventually this becomes a 16 over pi squared. Maclaurin series y up to including the term x squared. So I will not solve differential equation anymore. This is too much. So this can be Maclaurin series. So now we have f0 negative pi over 2. Pi over 2. F prime of 0 here, dy over dx with x0 and y negative pi over 2, negative pi over 2 tangent 0 cos 0, which is 1. So dy over dx is 1. And we need to find the second derivative from here. So the squared y dx squared minus dy over dx tan x plus y sec squared x becomes negative sine x. So now I will put numbers here without like rearranging it. So here x equals 0, y equals negative pi over 2, dy over dx equals 1. So second derivative, 1, 0, negative pi over 2, 1, negative 0. So here pi over 2, which means second derivative negative pi over 2. So now we can find y equals negative pi over 2 plus x negative pi over 4x squared, blah blah blah. And let's go for the population. So dy over dt is expressed here. So differential equation doesn't have a lot of applications actually. Most of the applications are from the separation form, like proportional to, inversely proportional to, something like that. So here, dy over y, k cos kt, dt, integral, integral. And then y is k sine kt plus c. So y is e to the power of sine kt plus c. Let's see e to the power of ca, then y equals e sine kt. So now when t equals 0, y equals y0. So which means a is y0. E sine kt. So ratio of minimum size of the population to the maximum size of the population. Oh, okay. Because sine kt goes to negative 1 to 1. So maximum happens when sine kt is 1, and minimum happens when sine kt is negative 1. So minimum y0, e and negative 1. So y0 over e. Maximum y0, e to the power of 1. y0, e. So here, minimum to maximum. So like this. So this becomes y0e times 1 over y0e. So 1 over e squared. This is the ratio. 34. This is the differential equation of homogeneous case. You can try to do that. And 35. So e to the power of ex minus 1. So Maclaurin series e of x. And yeah. So now we have e of x there. So 1 plus e of x minus 1 plus e of x minus 1 squared plus let's go another one, e to the power of x cube, because it shows onto 3, so just in case I made it like that. And still it's 1 plus x squared over x 2 factorial plus x cube 3 factorial and plus a factorial 1 over 2 factorial and x plus x squared 2 factorial x cube 3 factorial x plus x squared x cube 3 factorial 1 over 3 factorial. Here I'll write down only like this because it's very obvious. We don't need x cube because we need to multiply them 3 times. So already this is enough. So 1 plus x squared over 2 plus x cubed over 6 plus 1 over 2 factorial x squared plus 1 over 2 factorial, 1 over 2 factorial, x cubed, yeah, plus 1 over 3 factorial, x cubed, plus blah, blah, blah. We don't need anything further. So now this one, 1 plus x plus 1 over 2 x squared, plus 1 over 6. This is 1 over 2, 1 over 6, x cubed. So this is 3 over 6. So it becomes like this. So hence or otherwise. So we make that. So now we know we have this one. So we know f prime 0 is 1. So this one is 0 over 0. So which is indeterminate form. Because it is indeterminate form, we use L'Hopital or the Maclaurin series. If not, we don't need to do that. So now let's go further. Since we have it, let's use the series. F prime of x is 1 plus 2x plus 5 over 2x squared, blah, 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 minus 1. 1 plus x squared, 5 over 6x cubed, blah, 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 minus 1. So when we divide by x, 2 plus 5 over 2x, blah, blah, blah. 1x, blah, blah, blah. Because all these blah, blah, blah terms will go to 0 when we input 0 into x. So this is 1 over 2. And, yep. This is again homogeneous. Yeah. So like this style, here Maclaurin series for 1 plus x. So now there is no the form of 1 plus x to the power of n, but we have this binomial extension. So we can use that to find this form, this one. This one comes from also this Maclaurin concept, so you can use that. So now we can make the arctangent here. Let's do that. So here 1 minus x squared negative 1 over 2 is a is 1 to the power of 1 negative 1 over 2, which is 1. So I will not write it down. 1 minus 1 over 2 negative x squared, negative 1 over 2 negative 3 over 2 over 2 factorial x negative x squared blah blah blah. So here 1 plus x squared over 2 plus 3 over 8 x to the power of 4 plus blah blah blah. So this is this one. This is 1 over x squared. Arc cos x. This has the formula of its derivative. It's negative 1 over square root 1 minus x squared here. So I will put all negative sign here. So negative 1 over square root 1 minus x squared is negative 1, negative x squared, negative 3 over 8. So when I integrate it on both sides, left side comes arc cos x equals c minus x cubed over 6 minus 3 over 40 x to the power of 5, blah blah blah. But when x equals 0, arc cos is pi over 2. So pi over 2 is c. That's why it becomes like this. Because cos pi over 2 equals 0. That's why arc cos pi over 2 is 0. So evaluate this one, because now we have this one, so we can put it and find it. So if you want to find this one, we substitute x into square root of x, and we can sort them out. And the further, yeah. So like number 43, we already have this cos x here, so we input x to the power of 6 here into x, then we can solve it out. And 45, e to the power of x and e to the power of, okay, yep. And 46, yeah, this is the integrating factor, you can find it. 48, let's try this one. So cos squared of x e to the power of y is e to the power of y dy over dx. So e to the power of y, e to the power of e to the y dy equals cos squared of x dx, integral. So cos squared of x, when we use cos double angle identity, this is 1 over 2 cos 2x plus 1. And this one, when we substitute u of e to the power of y, then integral eu ey dy is du, so du, so eu plus c, but u is e to the power of y, becomes 2, let's say, and sine 2x over 2 plus x. So now when x equals pi, y equals 0. So 0 to pi e to the power of 1 plus c. C is pi minus 2e. So when we go further, sine 2x over 2 plus x minus pi plus 2e is over 2. It's e to the power of y. So when I make, like on both sides, apply ln, then ln 4 sine 2x plus 2x minus 2 pi plus 4e is e to the y. So another ln. So ln of ln sine 2x minus 2 pi plus 4e over 4 is y. Wow. So find the value of y when x equals to pi over 2. Yeah, we can put it in. Nothing strange. ln. Yeah, here actually when I apply the both sides the ln, I don't need to put this modulus sign, sorry. So ln 1 over 4 sine pi 0 pi minus 2 pi plus 4e. Oh, sorry. So y equals ln of ln 4e minus pi. And acceleration again. So dv over dt equals to negative 1 over 2v, and you can solve it out. That's it.